Hi everyone, so this is our last lesson in chapter 8 and it's all about symmetry. And we talked kind of a little bit about this when we did reflections because that line of reflection is like a line of symmetry and it creates a mirror image on either side. But now we're going to go into a little bit more detail about what kind of symmetries different shapes can have. So a symmetry is when there's something that can do a transformation that will land the figure exactly on itself. So, like I just said, the line of rotation makes it equal on both sides. So, we have three different types of symmetries, and those are line, rotation, and point. Okay, so let's take a look. So, a line symmetry is when there's a line that maps the figure onto itself. It's like the reflectional thing that we were just talking about. We can have a rotational symmetry where you can rotate it 180 degrees or less and it lands on itself. It's the same. And then down at the bottom, we have point symmetry where if you rotate it exactly 180 and it lands on itself. That's point symmetry. So in class, we're going to be doing some stuff with these, which we'll do next class. But for now, we'll go on to our examples on page 2. So for the first questions, it asks us to draw all of the lines of symmetry that can go through the shapes. So I'll do number 2 with you, and then you can try 1 and 3. So for this one, for it to land on itself, in problems like this, we're assuming that all of those sides are congruent, unless they're obviously not, like the top and the bottom here. But for this one, it's just going based on appearances. So we could flip it over that line or that line, and then it will be a reflection. So go ahead and pause, try 1 and 3, and I will show you all the lines of symmetry when you come back. Okay, so for example 1, we had 4 different lines of symmetry we could draw. Obviously I didn't draw them very good, or they would all meet in one point in the middle, but you get the point. And then number 3, there was only one straight down the middle that would make this half land on that side. So for questions 4 through 6, it says to tell if it has rotational symmetry and then give the angle of rotation. So to figure out the angle of rotation, we do 360 divided by how many pieces it has, kind of just like what we did with the exterior angle formula. It's kind of actually just like that because we would do 360 divided by the pieces if the pieces look to be congruent. Like here it looks like this is an equilateral, equiangular triangle. So that means that we would have to turn this figure 120 degrees to make it land on itself, so it would have rotational symmetry. As far as number 5 though, no matter what I do to turn this, it's never going to look like it did before because the pointy part was on the bottom with the longer flat side at the top. This one looks like isosceles. So to get it to be exactly the way it is right now, we'd have to spin it all the way around. So this would have no rotational symmetry. So what do you think about example number 6? If I spun it around with that point being our center, how much would we have to turn it to make it look exactly the way it did before? Good. It would be exactly 180 would get it the way it is because we have 2 opposite pieces that are congruent, so 360 divided by 2. So that means that it has point symmetry because it was exactly 180. Okay, so why don't you try example 7 and 8 and see what you come up with. Okay, so neither of these figures had any line symmetry, but if we take a look at 7, that one was kind of like 6, so this would have point symmetry. As far as number 8, we have 6 separate pieces here. So to figure out the angle of rotation, we would do 360 over 6. So that means we would just have to turn it 60 degrees to have it land on itself. Okay, so I know you're like, why is there a blank page there? I will show you what to do in class. Don't you worry. Okay, so the rest of these problems I want you to try to answer yourself. We'll go through the answers and talk more about them in class based on just what we kind of talked about with line symmetry, rotational symmetry, and point. Okay, so go ahead and pause. When you come back, we'll talk through the rest of these answers. Actually, I changed my mind. We will talk about them in class because I want to make sure you answer them on your own instead of just copying down my answers. So, answer all of these questions right now, or else we're in or out.